students, welcome to class. Welcome to class this morning. How you doing? Wherever you may be. Today we'll be looking into the topic image formed by curved mirror. Image formed by curved mirror. Actually, you have two types of curved mirror. We have the convex mirror and we have the concave mirror. But today we'll be looking into the concave mirror. Why we're doing this is because your convex mirror can just give you this an erect, diminished, and virtual image. Okay, that is the kind of image a convex mirror will always produce, no matter where the object is being placed, no matter the location of the object. You always have a diminished and erect and a virtual image being produced by what? By a convex mirror. An example of a convex mirror is the side mirror of your car. Okay, it's the side mirror of your car. That's why you can see that when you're using your side mirror, regardless of the position of the car coming behind you, you will always see a smaller image in your side mirror, and that's why it's always written there that images or car seen inside this mirror are always larger. Images inside this mirror are always larger than the scene and closer than they look. Okay, so that's just one thing about convex mirror. But when you talk about concave mirror have will produce different images with respect to what? To the location of the object. So case one, when the object is placed far beyond the center of curvature. Now, one thing is this: we have what we call the pole. We have the pole. We have the principal focus. We have the principal axis, which is the line. Okay, and we have the center of curvature. Okay, let me quickly make a reference to all what I've said. Okay. Looking at this. Okay, these are principal axis. Okay, this is the principal axis. Now, this point here is the principal focus, because this is the point. All the light rays seems to converge on the what? On in a concave mirror. Concave mirror is a converging lens, so it converges all the rays. So all the rays of light that hit the concave mirror will converge at this principal focus. Okay, and this is our center of curvature. Center of curvature is said to be the center of a circle in which the mirror itself is a part of. What am I saying? Let's look into this. So, and you can see that your center of curvature is at the middle. Okay, it's at the middle of the whole circle. So we say center of curvature is the center of a circle in which the concave mirror is part of. It's part of that complete circle. So let's quickly get down to business and get things done. Now, one thing is this. I think it's another thing for you to note. The distance between your between the principal focus, the distance between the principal focus and the pole is called the focal length F. It's called the focal length F. And whatever your focal length is, if it is 2 meters, if you're having 2 centimeters here, you must also have 2 centimeters here, because the distance between your center of curvature and your principal focus tool is focal length. So they're having equal distance. If you're having 4 here, you must have 4 here. If you're having 3 here, you must have 3 here. Now, let me quickly say this. The distance between, okay, maybe I should just write this for you guys. Let me just write it for you guys. Okay, let me just quickly write this. I hope this will help you. I'm doing this. I could have just said it, but I think this will help you. So the distance between the center of curvature and the pole P is called radius of curvature. Radius of curvature. We call this radius of curvature. Now, radius of curvature R. Radius of curvature R, and the R is equal to 2F. Yeah, and comma, and the R is equal to 2F. Okay, so look at this, look at this quickly, look at this quickly, look at this quickly. From here to here is called radius. Let me get a let me, okay, let me use red like this, okay. Okay, so from here to here, from this point here to this point here, we call that radius, which is just r. Okay, we call that r, small letter r. And from what you have on the board, you can easily say that our radius equals to what? 2f. Okay, our radius equals to 2f, which means the focal length is half of what? Half of your radius of curvature. Your radius of curvature. We call it radius of curvature. So now let's quickly go into this. Remember, we said that look at this. I told you that the distance between your center of curvature is actually the midpoint of a circle, which means that from here, from this point here to this point here is a what? Is a radius. So now, if everything here, if all this is our curved mirror, how do we draw that? All we need to do is to get the radius and then we make our arc to form a semicircle. So let me quickly get my tool. Let me get my compass. And as we have said there, what I did here, okay, let's bring in our ruler. Let's bring in our ruler back here. The O principal axis is 30 centimeter, okay, and we can see that from here to here is our what? Is our focal length, okay, and at this point we're having our principal focus. You can see that there is written capital F principal focus. Let me take it back. So let's see. Let me set. Okay, I think I'm set. Okay, so this is 30. Focal length here is 5, and then over here we have 5. So let's see, this is from 31, 2, 3, 4, 5. Then from here to from your focal length here to your center curvature here must be 5, and that's another 1, 2, 3, 4, 5. Yes, good. So now let's draw, which means our radius is now what? 10, because this is F and F. Okay, we have an F here, another F here, which means F of F plus F will give us R. Okay, yes. So now to draw that, what we need to do is to bring in our what? Bring in our compass. Let's bring in our compass and let's see. Okay, are we good to go? Let me see this. Let me just, okay, let me check. This should be like, oh yeah, I think we are good to go. I think we are good to go. Okay, so let's draw this. Let's do this. Let me draw my hack. Sorry for that. Let's take this away. Let's bring this down. Okay. And somebody be like, what is he drawing? Okay. Now, if I continue this, we actually form a circle. You can see that. You can see that, right? Oh, but let's go back. Oh, okay. So now you can see that that actually formed a circle, but what you're looking for is a curved mirror. So that's why I'm going to be doing this. Okay, now this is our curved mirror. This is our concave mirror. I want to believe that this side is silver, this coated. This is our concave mirror. Now the first question that when the object is placed, when the object is placed far beyond the center of curvature. This is when the object is placed somewhere around here or around here, at least it's just behind the center of curvature. Now, so let's get our image, our object placed. Let's get our object placed. So when you have your object like this, a lot of things will happen. You have a lot of ray coming out from this object. Normally, you have about 3 different type of rays. The first one, let me quickly do this, and let's go back to black. Okay. The first ray will come from the top directly and hit. Yes, and hit the screen, the mirror rather. Once it hit the mirror, another thing that happens is this. Okay, I'll make, okay, calm down. This ray hits the mirror, and after it hits the mirror, this is what will happen. You will have it coming back. Okay, you know, they will always converge. Don't forget that we are dealing with what? We are dealing with concave mirror. So all the rays of light that hit the mirror converge at the principal focus. So the ray will pass through the principal focus because it's converging at the principal focus. So let's say it goes like this. And that's because I want to extend this a bit. This one I want it to come down. Okay. Now that's that. That's the first one. The next one is this. You have another ray coming from the same object. Okay. This one is still coming from the object. And let's customize this a bit. Let's customize it a bit. Let's use which color should we use? Okay, let's use this. Let's use this. Coming from the object, and we pass through your what? Your focus directly. This will pass through your principal focus and hit the what? And hit the mirror. Okay. Now, when this hits the mirror, normally it will also go back. But now this one will not go back through your principal axis now. No, your principal focus rather. No, this one will not go back through your principal focus. But in this manner, this is how it will travel. It will travel like this, like this, like this. Now it hits the mirror and it will travel backward like this. Now, anywhere these two meet, anywhere they meet, anywhere these two meet, your image will be formed. But there's one more ray. There's one more ray that's also coming from what? From the object. And let me see, which color should I give to this one? Should I give this blue or this blue? I'm going with any blue. Blue. Okay, let me give it this color. And this one is coming from here, but this will pass through the center of curvature. Let's see, this is not actually really straight, but I will adjust that anyway. Okay, so this is what we're talking about. Now this one will pass through the what? Through the center of curvature. But at this point, you will have your image formed. At this point, you have your image formed because this is where these two rays have met. Now look at this. This ray started like this, moved straight, and as it got here, it changed direction and started moving downward. At this point, your image is now inverted. Yes, your image is now inverted. The object is upright, the rays of light is moving, is going like this, upright, hit the mirror, then turn downward, turn upside down. So at this point, you are having what? You are having your image formed inverted. And look at this one too, right from the top. Look at the head. The head is coming downward, hits the mirror, and comes backward. Then you have your image to be formed around here. But something about the image formed is that the image will be let's use what color should we use our image now. Let's use this color. The image formed, let me change the color. Now I wish I can zoom in this. I wish I can zoom in. Seriously, I wish I can zoom in. But from what we have here, look at this. Let me quickly use this to explain. These are our objects. Okay, good. Let's see what. Oh, what did I use to draw this? What did I use to draw this? Okay, length show in centimeter. The object is 3.3 centimeter. And what about our image? You can see that. Look at this. This is object. Object is what? 3.3 centimeter. And the image is what? 2.21 centimeter. So if you want to say what is the characteristics of the image formed by the concave mirror when the object is what is placed beyond C. Now image formed is 1. I say diminished. Diminished. Yes. The image is diminished. Consider the object is 3.3 and the image is 2.1, which means it is slower. It's smaller rather. It is diminished to, what can we say again? What can we say? What can we say? It is inverted. Yes. It will not, this one, the image from is upside down. Remember, I told you when I was mentioning this, I said something about this going straight and turning down, and this one to coming downward and moving like this. So which means it has turned upside down. It has turned upside down. It has turned upside down. Okay. And what's next one? The image is diminished, is in fact inverted. What else? What else? Now, the image here is real. The image formed by this mirror is real, very real. Now, the image is real. That's because if you place your screen, over here, your image will be formed on your screen. You can see that instead of the image being formed around here or inside the mirror, you know it is being converged through the words, through the focal principal axis. So if you put your image, your screen here, the image will form on your screen. So the image is real. The image is real. The image is diminished, inverted, real, and what? Then what about the location? What is the location of the image? The image is formed where? It is formed between the words, between the center of curvature. Look at it. This is the image, right? This is our image. And it is formed between the center of curvature and the principal focus. So let's quickly put that down. So I can say that for the image is between the center of curvature and the focal principal focus. between the center of curvature and the principal focus. And those are the four qualities or the four characteristics of image formed by what? A concave mirror when the object is placed beyond C. When the object is placed beyond C. Good. That's all about that. And let's look at case 2. Let's look at case 2. When the object is placed on the center of curvature. So now let's bring our object. Where's our object? Okay, this is the object. We are bringing the object to the center of curvature. Okay, now let's bring in the first ray. Okay, this is the object, and now the first ray of light. Okay, it's in the mirror. Okay, now this is the first ray of light. It's in the mirror, and when this happens, you have another ray of light that will be coming from the mirror and passing through your what? Passing through your principal focus. Let me show that pass through the principal focus. Are we good? Okay. Okay, let us know that's it. Now, after that, what happens is this: another ray of light is coming from what? From the object passing through the focus again. Okay, and that too will also hit the mirror, and then when that hits the mirror, what happens? Another ray will come back, another ray will be reflected. The ray will be reflected. Oh gosh. Okay, somewhere here. Now you're having these two rays hitting up here. Now let me say this: the major reason why I'm trying to draw like this is so that you don't cramp all the position of the object and all the images that will be formed. Okay, conventionally, this image supposed to be formed on the center of curvature. It's supposed to be formed here. It's supposed to be somewhere around here. But from what we are seeing here, our image is being formed somewhere close to this. Let's see, is there any mistake? Have we done anything wrong? Have we done anything wrong? I'm not sure. I would just want to take this up a bit. Okay, let's see. Now let's draw the image. Let's draw the image formed. The image formed is in okay, it's in pink. From here, our image has been formed. Let's draw it and let's go upward. Okay, that's very close. That's kind of very close. That's just very close. Okay, and we're having 2.1. Let me see. Let me see. Would that be? Okay, that's very close actually. That's very close. So we're having that to be what? 2.0 centimeter, 2.0 centimeter. And you see, for this, I can now say, I can categorically say this. I can categorically say this that for image, for object placed on this placed on center of curvature, image formed will be what the first thing is that same size. The first thing that the image is same size, same size, same size, same size as the what? Same size as the object. The image form is same size as the object. Yes, same size as the object. Then the next thing, it is also real. Okay, because if you place your screen over there, you will see that it will be formed, and besides you have all the rays of light coming together to converge. Okay, you have all the rays of light coming together to converge here to form the object. What I'm saying is this: you have this ray coming like this, hitting this, then coming back here to form. You have another ray here coming straight here, hitting the mirror, coming backward here to form, and it is the same. It is that actual the ray of light that were reflected, that were incident rather on the mirror, that came to form the image. So that shows that it is real. Then what is the next thing that we can say about this? It is real. Yes, same size as the object, real. Now it is also inverted. It is still inverted. The image is still inverted. And what next? The next thing is that um the position. Yes, it is formed naturally. This is it should be completely on the what? On the curvature, on the center of curvature. So which means the object will be on the same position as the image, but now the image will be inverted on the center of curvature, on the center of curvature. That's about that. Good. Now let's move on to the next one, which is what? Let's move on to the next case, and that is when the object is placed between the center of curvature and the principal focus. Now this is the case 3, when the object is placed between the center of curvature and the focal length. What happens at this point? So let's just place our object there between the center of curvature and the focal length. Then we know what will happen. The first thing is that the top ray of light, this is coming from here. It's the mirror. Then the ray will be reflected. It's a converging mirror. The ray will be reflected through the what? Through the principal focus. And then we have another ray still coming from the object and passing through the principal focus downward to hit the what? To hit the mirror. We have that. And we have this. Okay. So let me just make this. Fine. Now the two rays of light has met, right? Now what happens here? At this point, we have an image formed here. They have met. So the image will be formed where they have met. So what do we do from here? Let me just make this longer. Okay. Now from what we have here, let's look at this. We have our object, which is what 2 centimeter, and our image, which is what 3.6 centimeter. Okay, 3.6 centimeter. Yes, that's 3.6 centimeter for the image, and this is what 2.0 centimeter for the what for the object. You can see this 2.0 centimeter for the object. So coming down back here, I can say that this is the image formed is 1. What is that? When the image is bigger than the object, magnified. I say that the image is magnified or enlarged. Okay, image is larger than the object, magnified or enlarged by the mirror. Then what's the second case? It is still real. Okay, all the images are still real at this point. Then it is still inverted. This is very easy. It is still inverted. Oh, come on, Z. Oh, sorry. It is still inverted. And for the last one, what about the position? Where is the image formed? The image is formed beyond the center of what? Beyond the center of curvature. Yes, the image is formed beyond the center of curvature. And that's that. We have all for the case 3. Now let's go into the case 4. When you place your object on the principal focus, what are you expecting, or what should you be expecting? Now let's place our object on the principal focus. Oh, sorry. Now this is our object on the principal focus. So we know what will happen. The first ray is hit the mirror. And when that happens, the next thing that follows is that there will be a reflected ray. Okay, that will be converged to the focus, to your principal focus. You have that. Then one ray that has been missing since. Now you can see that this ray, this particular ray, is this one? This one that used to pass through the focus up and down since. What I'm saying is this, what I'm talking about is this. This ray, this particular ray, there's a ray here. This particular ray, this one. I see that it's always coming from the object and passing through the focus downward. But in this case, the focus, the object is already on the focus. So this particular ray will not be able to do its job there, but it will now come into this form. This is where it will now be formed. The ray will now be coming from the object and will be passing through the center of curvature. You can see that. See, it's not passing from the object here, going up and coming downward. So it hit the mirror and traveled backward. It hit the mirror and traveled backward. Now, this is a very serious case. Let's see where they will meet. Don't forget that it must continue passing through the focus. And this one must continue passing through your center of curvature. let's go down a bit and let's see if this will actually meet. Don't forget your focus. It's important. Don't forget your center of curvature and the tip of the image, the object over there. Wait, uh, uh, this I'm not sure this two is going to meet at all. It's like they're even going far apart. Okay, no. Okay, this is the issue here. Okay. But with what I'm seeing here, this image will not form. So in this case, since the image is not forming, we just come over here and say and tell them that image is formed. It's formed as infinity. Image is formed as infinity because we cannot see it on the screen. The image is not appearing on the screen, so the image is formed as infinity. And see how the rays of light keep traveling downward. Okay, the image is formed as infinity. We don't know if it's real, we don't know if it's virtual, we don't know if it's anything, but it's going to be formed as infinity because we can't see it on the screen right now. Okay, so what do? We leave it as that. Let's move on to the case 5, which is the last case. Okay, welcome back. Now the case 5, when the object is placed between the principal focus and the pole. When the object is placed between, let's do that. When the object is the object, let's pick the object. Let's put it anywhere between the principal focus and the pole. You can anywhere you want. You can keep it anywhere you want. It doesn't matter. Anywhere you want. So we've done this. The first thing, as usual, this ray. This is the first ray that we always use. It's the mirror. And immediately it's the mirror, what happens? It gets converged. That is, it will reflect through the principal focus. Yes. Then after that, we have another one. This one is coming from the object and passing through the center of curvature. Be careful, make sure that it's actually have contact with the tip of the object. Now, if we look at this, I can, hold on please. In this case, if we try to extend this behind the mirror, for example, let's come over here and let's extend this color is this and this, or let's say this. Let's try and extend this beyond the mirror. That is supposed to be. Straight, right? Okay. Just want to be sure it's actually very straight. Let me change the color. Couldn't change the color. Okay. We have this extended backward. Now let's have another extension. This time, let it be green. Okay, I'm supposed to let me use this. And I want to be sure it's straight too. Okay. Okay. Now looking at this, and let me extend this P. This line is the principal axis. Let me extend it back to this line. Okay. Now you have this. The image in this case is being formed behind. Not like, look at this other case here. Look at this other case. Even if we should extend this to like this and like this, they will still not form any image. No image will still be formed. The image will still be formed at infinity because we don't see it. But in this case, let's see our image. Where's our image formed? The two rays have met behind the screen. Now, we can see that the image has formed behind the screen and the image is 5.5 centimeter. Now look at this, look at something. Consider the ray is coming from the top of the uh from the top of the object, and this one coming and going up. Now this time around it's not coming down. Okay, this time around this is not coming down. So what do we have? We have an erect image. Let's first of all do that. We have an erect image. So what's the first thing? First thing is that our image is erect. Oh, Control Z. Sorry. Our image is erect. Erect, yes. It is magnified. Now it is virtual. Like I said, the image is not, look at all the other images. Look at what we always have here. Look at them here. Okay, this one doesn't have any image formed. Look at it. The image is formed on the screen here. Look at this one too. Also formed on the screen here. And say it's real. Look at this one too. Also formed on the screen here. All these are real images. All these three are real images. But for this, it is virtual because it is being formed behind the screen. And you'll be seeing this image. Okay, now let's say you have an observer here. An observer here, I mean, this one what I'm talking about. Let's say we have an observer. So somebody is here. Okay. An observer here will be seeing those. Okay, let's say we have an observer here. Now, this observer will be looking at the image inside the mirror as if it's forming behind the screen, just like we have in our plane mirror. Can you remember? So in this case, this will be what? This will be virtual. This will be virtual. You have to erect, magnified, virtual. And what else? It's not inverted. It is magnified, doesn't diminish. It is virtual, and it is formed behind the screen. Formed behind the mirror, rather. Behind the mirror. Okay, formed behind the mirror, erect, magnified, and what? Virtual. So these are the 5 types of images that can be formed on a concave mirror with respect to the position of object. Let's make a quick recap. The first one, when the object is placed far beyond, when the object is placed far beyond the center of curvature, you have the object here, you have your image from there, and that is the image is diminished. That is, it is smaller, you can see 3.3 centimeter to 2.2 centimeter. The object is bigger than the image, inverted, upside down, real. It is being formed on the screen, then the image is between the center of curvature and the principal focus. Then we move on to the following one, which is when the object is placed on the what? On the center of curvature. Now this is the object on the center of curvature. We have the image at same size. The image is same size as the object. You can see object is 2. Look at the object, 2 centimeter. And then what do you have of the image 2? So look at the image 2. This is the image. This is for the image, you know. That's for the image. We have of the image 2. We have for the object 2. 2 centimeter, 2 centimeter. So we say they are what? They are same size. They are same size. It is real, can be formed on the screen, inverted, upside down, and it is also formed on the center of curvature. Also formed on the center of curvature. Now let's move on to the next one. Image one. Okay, we say when the object is placed between the center of curvature and the principal focus. This is the object. You can see the image being formed there. The object is 2 centimeter. The image is what 3.6. That is what magnified or enlarged. It is magnified. It is real. It is inverted. And formed beyond the center of curvature. This is center of curvature, and the image is being formed there beyond the center of curvature. Then, this case, when you have the image, the object placed on the principal focus, this is the object here, and we couldn't even picture our image. We can't find our image on the screen anywhere. Okay. And the final case, when you have your um, when you have your image, when you have the image on the what? On the between the focal length, between the principal focus and the what? And the pole. What do you have? You have the image being formed behind the mirror, and it is magnified. It is erect, standing upright, erect, magnified, virtual, and formed behind the mirror. From behind the mirror. So these are all the image formed by concave mirror. We see in the next class. Thank you very much.
I believe the knowledge is power to unlock inner potentials. Opportunity.